Good morning. In this video, we are going to discuss step response of RC circuit. This is the subject regarding electric circuits too. That means transient response of electrical circuits. So, the first question here is calculate the capacitor voltage for t less than 0 and t greater than 0 for each of the circuits. Step response means it contains after t equal to 0 the circuit contains the source, either current or voltage. So we have here two questions. In the first circuit we have 20 volt source, and this is 4 ohm resistance, and here we have capacitance, and here is the switch. So first of all, when t is less than 0, so the switch is closed, and after t equal to 0, the switch is open. This you need to understand. Coming to the solution, when t is equal to 0, t is less than 0, first we will calculate RC. Depending on this circuit, we will calculate RC, and also we will find V of 0, that is t is less than 0, and V of infinite, t greater than 0. So what are the values we need to find? This is the formula for RC circuit for step response. For step response, this is the formula. So we need V of 0, that is t less than 0, the voltage of capacitance, and V of infinite, that is t greater than 0. So first of all, we will find V of 0. This is V of 0 actually, not V of t. So when t is less than 0, what is about the switch? This is the circuit. The switch is closed. When the switch is closed, then for a long time the switch is closed. At t equal to 0, it is open. So for a long time the switch was closed. So the whole voltage 20, the whole voltage will not appear here, but we need to find here by using voltage divider formula. You will get, why? Because the switch is closed here. By using voltage divider formula, you will get the voltage V of t, that is 4. You can say V of t, that is V of 0, it is 4. Now we will find t equal to 0, t is greater than 0, then we will find tau. Tau is RC. RC is the time constant, it is known as tau. So we need tau also here. So 4 into 2. When t equal to 0, the switch is closed here. The switch is closed. When the switch is closed, these two, the source voltage will be short circuited, and 4 and 1 will be in parallel. 1 will be parallel. So you will get like this. Okay, when this is open, the switch is open when after t equal to 0. So in the whole circuit you will get 4 ohm resistance and 2 farad, the capacitance 2 farad. So 4 into 2 will be, the time constant will be 4 to the 8. Here it is 4 into 2 equals 8. And when the switch is open at t is greater than 0, the circuit will appear like this. At the same time, you have to calculate the RC value, time constant, as well as V of infinite. That is, the whole voltage will appear at capacitance, that is 20. At when the switch is closed at long time, then the whole voltage will appear. The source will be appear at capacitance. Okay. This is the characteristic of capacitance. So V of infinite equals 20. Then substituting in the formula, V of infinite is 20 plus V of 0 is 4 minus again V of infinite is 20 multiplied by e power minus t by tau. Tau is 8 we got. This is the final answer for this question. Then coming to the next question, the same question, bit B. Here you can see the switch is closed at t is greater than 0, t equal to 0. That means before t less than 0, the switch was open. The switch was open. You need to understand this. When switch is open, find out V of 0. Here is the solution for this. When t is less than 0, the switch is open. So the voltage V1 and V2, whatever you get by this, you can convert this current source parallel with 4 ohm resistance can be converted into voltage source and series with the same resistance by using source transformation theorem. Source transformation theorem says that when current source is in parallel with the resistance, it can be converted by using Ohm's law. V equals IR. V here is 2 and R is 4. 4 to the 8. 8 volt will be the source. The current source will be converted into voltage source and its value is 8. 4 multiplied by 2, 8. And the same resistance in series. It can be replaced like this. So when t is less than 0, these two voltages will be added. But since if you go in clockwise direction or anti-clockwise direction, it's your wish. If you go in clockwise direction, minus 8 plus 12, it will be 4 plus 4. So you will get V of 0 equals 4 when t is less than 0. Now when t is greater than 0, the switch is closed. When the switch is closed, you can see the circuit here. When the switch is closed, you will get this circuit: 2 farad capacitance and 3 ohm resistance along with 12 volt voltage source. You can have here, see here. This circuit, you will get this. Now find out V of infinite. V of infinite will be 12. When the switch is closed here for a long time, the whole voltage will appear at the capacitance, that is 12 volt. And what is RC? Time constant RC will be 3 multiplied by 2 will be 6 seconds. Now substitute in the formula, V of infinite, that is 12, plus V of 0, 4, just now we found 4 here, minus V of infinite multiplied by e power minus t by tau. Tau is 6. Okay, this is the final answer for this. Coming to the next question, find the capacitor voltage for t less than 0 and t greater than 0 for each circuit. So this is the first circuit we have. When t is less than 0, the switch is connected to 12 volt supply, whereas after t is greater than 0, the switch is connected to 4 volt supply. 12 will be disconnected after t equal to 0, and before t equal to 0, t is less than 0, 4 will be disconnected. We have two circuits here. So before t equal to 0, that is t less than 0, the source 12 volt is connected to the whole circuit. Now you can find RC here. So the voltage, you need to find the voltage V of 0. V of 0 will be 12 volt. The whole voltage will be supplied to the capacitance. This is V of 0. When t is greater than 0, the circuit appears like this. 4 volt source is connected to the circuit and 12 volt is disconnected, and we have RC. You can find the value of RC, time constant tau, that is 3 into 2 equals 6, and you need to find the voltage here. What will be the voltage here? V of infinite 4 volt will appears at the capacitance after t equal to 0, t is greater than 0. Now directly you can substitute all the values. V of infinite is 4, V of 0 is 12, like this, and tau we got as 6. Now you can substitute in the formula, you will get the final value of V of t. Now question number 2. In question number 2, the switch is on the top. It is closing. Closing means when t is greater than 0, this connection is this will be the connection, and 4 will be removed when t is greater than 0. Whereas t is less than 0, this connection is established, and when t is less than 0, there is no connection here before t equal to 0. So this 4 ohm will be connected. This you have to understand. Here again you have one current source and resistance. This can be converted into, by using source transformation theorem, we can convert this current source into voltage source. 6 to the 12, 12 volt will be the voltage source, along with series resistance as 2, the same resistance in series with the voltage source. You have to convert into the next step. So before going to the solution, you have to understand this. There is a connection here. When t is less than 0, then there is no connection here. So 4 ohm resistance is connected here. When t is greater than 0, there is no 4 ohm resistance, just it is a connection like this. There is a connection like this, and 4 will be removed after t equal to 0. You have to understand. Going to the solution here, before t equal to 0, that is t less than 0, there is no connection here. That's why 4 has been connected. Now we will convert this current source into voltage source. As I said before, 6 to the 12 will be voltage source. It is plus, it is minus. The direction of current source is upward direction. That's why plus will be on upside, minus will be on downside, by using source transformation theorem. And 2 ohm will be in series, it becomes series, and 4 is as it is. Now you got the circuit. This is t less than 0. Now what is the V of 0? Very simple. The whole source will appear at the capacitance before t equal to 0. So V of 0 is 12 directly. Now after t equal to 0, here is one connection of the switch, and 4 will be removed. It is the basic concept. So like this, the circuit will be like this. This will be closed, 4 ohm will be removed. Again this 6 ampere current source will be converted into voltage source, 6 to the 12 as it is. Now you can find the voltage source. voltage across the capacitance after t equal to 0. And what is Vc, sorry, what is tau Rc? 5 to the 10. 10 will be the, where is this? Here it is. Tau equals 2 into 5 equals 10 seconds. Whereas the voltage 12 volt will appear at the capacitance. This is V of infinite. Upon substituting, 12 is V of infinite plus V of 0 is 12 and V of infinite is also 12. Okay, before we got 12, before and after, both are same. So you will get the final value as 12. Going to the next question. Here also we have 12 volt source along with 6 ohm resistance. Here is a switch. At time t greater than 0, the switch is closed here. Before time t is less than 0, the switch was open for a long time. Now when the switch was open, when t equal to 0, t is less than 0, the switch was open. So there is no source here. That's why the voltage across the capacitance will be 0. It is shown. V of 0 equal to 0 when t is less than 0. Whereas t greater than 0, the switch is closed here, then 12 volt supply is applied to the capacitance like this. This is the circuit for this. Now you can find by using voltage divider formula, the voltage across the capacitance will be from here to here. So by using voltage divider formula, 30 is the the closed resistance, and divided by 30 plus 6. 6 is opposite resistance. The same resistance along across which the voltage has to be found is written as 30 divided by 30 plus 6. 6 is opposite resistance into total voltage. Total is 12. You will get V infinite as 10 volt and RC. How to get RC? RC is 5. See, to find RC, this will be short circuited and these two will be in parallel, 6 and 30. 30 into 6 by, it is not shown here, 30 into 6 by this parallel resistance. Find the equivalent of parallel. So 6 into 30 by 6 plus 30. It will give you 5. And 5 multiplied by 1, this will give tau, time constant. Upon substituting all the values, V of infinite, V of infinite is 10 plus V of 0 is 0 minus 10 e power minus t by 5, tau equals 5. You will get the final value as like this. So for today, this is enough. Thank you.